Hello, periods 1, 2, and 3. I wanted to walk those of you who are not in class today through our notes. So download the notes and then go ahead and do a side-by-side split screen so that you can fill in the notes with me as you listen to this video. A little bit of writing today. I went ahead and wrote in some of the definitions for us just to save time. So a few things with starting chapter 3, algebraic expressions. We need to memorize some definitions, okay? The quicker you memorize what these definitions mean, the easier this chapter will be, okay? So the first one, I already wrote the definition for you. An algebraic expression is a number phrase that may contain numbers, operations means add, subtract, multiply, divide, and variables. Variables are letters, X, Y, Z, A, B, C. Those are variables. An expression, we've talked about this before, means there's no equal sign. Okay, that would be an equation. So an expression, no equal sign. Okay, so there's an example for you there as well. 2x plus 7, that's an algebraic expression. It's got numbers, it's got letters, it's got operations, an addition sign. Okay? All right, write this next one in. Term. A term is a part of an expression. A part of an expression. Okay? So an example for a term would be maybe 3x. That would be a term. Or 15. That could be a term. Okay. If you look at this example up here, 2x would be a term and 7 would be a term. So it's just part of an expression. It's without the operation in the middle. Okay. A variable, we just said that a variable is the letter A, B, C, those are all variables. So a symbol or a letter that represents a number. Okay. Coefficient. Okay, coefficient, it is the number that comes before the variable, the letter. So it's attached to the letter. Okay. So if you look over here, examples, the example 2x, the coefficient is the 2. It's the number in front of the letter, the number attached to the letter. In 1.5y, the coefficient is 1.5. It's the number in front of the letter. Okay? So that's the coefficient. And then the last definition is constant. Okay? A constant is a term without a variable. Okay, meaning without a letter attached to it. Okay, so if we go back up to the example up here, 2x plus 7, 7 would be the constant. It's the number or the term without the variable. So 7 would be the constant. 2 would be considered a coefficient, the number in front of the letter. Okay, so now we're going to kind of use those definitions to fill out this chart. You'll definitely keep seeing this chart throughout the chapter, and then one will be at on the assessment at the end of the chapter. Okay, you have to know terms, coefficients, constants. Okay, let's fill out this chart together. First row, 12 plus 10c. Terms. Go back up to the term. A term is any part of an expression. It's just not the operation. Okay? So 12 is a term and 10c is a term. Coefficient. Remember the number in front of the letter. So 10 is the coefficient. And constant. A constant is a term without the variable or without the letter. So 12 is the constant. Think of constant as it's not changing. Okay. that 10c eventually will change because c could be 3, c could be 4, and you're going to multiply it by the 10. Okay? Terms for 15 plus 3w plus 1/2. Again, terms are a part of an expression. So 15 is a term, 3w is a term, 1/2 is a term. All of it except the addition signs. Coefficients, the number in front of the letter would be a 3. And the constants, it would be 15 and 1/2. Okay, hopefully you're getting the hang of these. Terms, z squared is a term, 9z is a term. Coefficients, the number in front of the letter. Every time you see a letter, there is a number in front of it no matter what. So what number is in front of this z? Okay, so you may or may not know this. This could be new. If you don't see a number in front, it is implied that it's a 1. Okay, we just don't write 1z squared. So coefficient here, this is a tricky one, it's 1 and 9. There's a 1 in front of that first z squared, and there's a 9 in front of the z. And then constants, is there anything that's by itself without a variable attached to it? No, so we're just going to write none. See if you can do the next two on your own. Pause the video, fill it out, unpause, see if you can get them right. Okay, terms, 3k and 11. Coefficient, the number in front of the letter would be a 3. The constant, a number with no variable attached, 11. And the last one, terms, 4x is a term, y is a term, 10 is a term. Coefficients, there's a 4 in front of the x, and what is in front of the y? A 1. If you don't see a number, it's a 1. It's a 1y there. And then constant would be 10. No variable attached to that. Okay. So go back, review that chart, review the definitions of terms, coefficients, and constants. Those are very important for this chapter. Next page, write this expression using exponents. You guys know how to do exponents. You guys have done these before. We do them with order of operations. The 5 is our base, and then you're counting 1, 2, 3, 4 of them. So 5 to the 4th power. It's another way to write 5 times 5 times 5 times 5. Okay, you can do the same with variables, with letters. Y to the 4th power. Okay, go ahead and fill out the rest of this part until you get down here, and then stop, pause, unpause, and see if you got these correct. All right, this would be d cubed, or d to the 3rd power. This would be h to the 4th power, y squared, y to the 2nd power, x squared, x to the 2nd power, w cubed, or w to the 3rd power. Okay, when you get down here, we have an 11, and then y to the 4th power. Remember, a number next to a letter means multiplication. So this does say 11 times y to the 4th. Right here, 1.5 times m to the 3rd power. And this last one, 9.2 times x, 1, 2, 3, 4, 5, 6, to the 6th power is how we would write these. Okay. Alrighty. Next, this says to evaluate. That word evaluate means solve, and that's what it's going to say on test, evaluate. Okay, so you just have to know that's a fancy word for solve. When you do these, I want 3 lines. I want you to write the expression. Then you're going to substitute in the number for the variable. It says k is 25, so substitute in 25 for k. We're adding 10. 25 plus 10 is 35. When it says show your triangles, that just means kind of like your order of operations, okay? it just kind of keeps getting smaller and smaller until you get it solved at the bottom. Evaluate. We're going to write the expression. We know that dot means multiplication when n is 19. So we're going to substitute in line 2. We're going to start solving in line 3. And box our answer. Okay. Evaluate. We're going to rewrite the problem. And I see there's a division problem in this, and division comes before subtraction, right? We're going to substitute in line 2, so we're not solving anything quite yet. We're just substituting. Now we can solve using order of operations. 24 divided by 2 is 12. Bring down your subtraction sign, and then 40 minus 12 is 28. Box your answer. There's that triangle. And this last one, evaluate. 14x plus 17. Rewrite it on the first line. Substitute in the second line. A number next to a letter means multiplication. And multiplication comes before addition. So we're going to do 14 times 5 first. And then addition. 70 plus 17 is 87. Okay, so that is day 1 of algebraic expressions. The notes. Remember that if you need more practice, or if you want to watch the video again, you can. Now that we've completed those notes, there is a practice day 1 underneath this video in Canvas. So go ahead and open that up, practice day 1, and do those practice problems, please. Reach